We're going to continue our discussion of surface plate equipment with the drop gauge and drop stand. In the last video, we talked about the surface plate, height gauge, test indicator, and the scribe, and how you can take measurements with that. You can do most of the same measurements with a drop gauge on a stand. However, you have more limited motion because you don't have a height gauge to raise and lower the indicator. But on the flip side, you do get much more travel with a drop gauge. You're going to get about 1 inch of travel or 2 inches, sometimes even as small as 1/2 inch, but it's still much more than you get with a test indicator. So that's one of the big advantages of using a drop style indicator. So here I've got a drop gauge stand. There's a couple of clamps on the side. You can unclamp and raise and lower the indicator to whatever height you may need. You've got a granite block, and what's most important basically is that the drop gauge is perpendicular to the flat surface. That way everything will be an accurate measurement moving up and down. Sometimes, that last bullet point I had to remember. When you've got a drop gauge stand, sometimes you can put this thing on a very, very large surface plate, and then you can flip this around and measure your parts with the parts with the drop gauge and the part resting on this surface plate, and make sure that this is perpendicular to the other surface plate. But that can be great when you've got a much larger rock to work with and big parts that don't fit on this little stand here. So feel free to flip it around. I, however, am going to use it pretty much as intended with a small part on a small stand here. The indicator itself, it measures in one motion. Again, you're manipulating this tip here. Get rid of that rattle. Okay, sorry about that. So it measures in one axis. It's normally attached, to a drop stand. Typical stroke is 1 inch. Like I said, you can get more. And you have an outer ring and you can rotate to set 0. So wherever this indicator happens to be when you set 0, just rotate the ring, and then you can clamp the ring down so you don't accidentally bump it, and it'll have some resistance when you try to rotate it. There will be a smaller dial that will show you the stroke. So on the picture there, here we go. You see that the larger dial is showing you, your reading, and the small dial is showing you your stroke from 0 to 1 inch. So when you over travel, you'll watch that small dial just stop basically. You have a little bit more than 1 inch, but not much more. And then what's nice about drop gauge is you have a lot of tips. So we can exchange this bottom tip by screwing it off. And we have a range of choices to choose from. Different styles, different sizes, pointed ends, round ends, flat ends. I'm going to put our flat end back on. So you have a lot of variety to choose from. They're typically used for simple distance checks. So, for example, you could set up a part, from you could set up your part and drop it to the base, set your 0, and then tell you the step height here, the next step height, and the next step height is as much as you can achieve. Yeah. Flip this around. So you can get that step height, and you can keep going until you run out of travel. But your limitations, of course, are the travel and the anvil tips. They're not typically used if you're going to be like sliding the part around, doing flatness, parallelism type checks. That's when you're going to go back to using the test indicator because it's better suited for that. It's also not typically used with a round part. There it is. With a round part and a V block. Just because a test indicator, again, it works a little better for this application than rotating it with a drop indicator, although I would say about 25% of the time I do find it's easier to use a drop indicator. It just depends on the situation. But again, you're dealing with a little balance issue sometimes and how much weight is applied by this moving indicator, whereas really no weight is applied with a test indicator. But you could do some run out or circularity checks this way as well. We'll cover all that again. As I mentioned, we're going to cover a video on V blocks and 1, 2, 3 blocks and how to integrate them into your inspections. And overall, this indicator, drop indicators tend to be very accurate. So feel free to use these interchangeably if accuracy is what you care about and you can do it with either gauge. Feel free to use either one. When you are setting up let me flip it around. When you are setting up the gauge, there is a clamp here that a nut or clamp or however that allows this gauge to pivot. So what you'll want to do is set up a 1, 2, 3 block when you're clamping this down, and just verify that you are perpendicular in all orientations of the block. You can use a machinist square as well if you have one. Either way, a nice 1, 2, 3 block or a machinist square will help you set this thing up perpendicular so that you're not at some extreme angle traveling and getting bad readings. Drop gauges themselves have many styles, more than just this one here. I have a couple more examples here. This is, in the previous video, I showed this one. It's a 50 millionths resolution indicator. I think it has 15 thousandths of range, 0.015, and it strokes out, which is pretty cool. It's for very, very accurate machining. A friend let me borrow. He also let me borrow this one. Set this down. This is a 0.2 travel, and again, also very, very sensitive. Only has 0.2 of an inch travel before it strokes out, whereas most of the ones you're going to come across have 1 inch of travel. But what's really important to note is what direction the numbers are going. So on this this indicator on the right, excuse me for 1 second. Sorry about that. So this indicator on the right, it has numbers going 0, 10, 20, 30, 40, 50, and then 40, 30, 20, 10, 0. So we call that a 050 resolution gauge, dial. Sorry. This other one goes 0, 10, 20, 30, 40, 50, all the way around to 100. And so we call that a 0100 dial. This one that I showed you before, it goes from 0 to 5 and then back to 0. Some of the gauges we're going to work with, let me see this one. This one's also a 0100. Some of the gauges might go 100 to 0. So they all have different styles and different secondary gauges, where they are and what direction the numbers go. And you just need to be aware of that as you're doing your math. What you're going to be doing is zeroing it, moving it, and checking which way, how far you traveled. Now, if you're zeroing it and going down, or zeroing it and then going up, will make a difference on which style indicator you have and how you do the math. So that's one area where people get a little messed up, is they're not looking at which direction the numbers are going, and they're making a mistake in their secondary reading after 0. So keep that in mind. Really be certain of which style indicator you have before you try to go and do a reading. Now, when we talk about tips, this set here is very commonly available. I've seen it in multiple places, and there's many sets out there with different tips, but and there's many more styles that you can get than just in this set. This is just one of many. But you can change the way your contact point is making it. So sometimes I like a big flat surface if I'm going to be measuring, on top of a diameter. And I might like a pointed surface if I have like a really tight clearance that I'm trying to drop my indicator onto, and I can't have a big bulky indicator tip. Sometimes this angled one is nice. If you look in the middle there, in the middle of the screen, there's an angled tip, and that will help you get into inside features, inside of holes, inside of slots. So when you use this one, that's a nice one. When you get this one on, it'll orient itself in a fairly inconvenient direction most times, but you can switch your gauge around, and then if you needed to, as I said, this is fairly inconvenient for the front-facing camera, but for the top-facing camera, you can then kind of get into the inside features of the part. So right now I could zero here on the granite rock, bring it up and find the bottom of the hole, and then use the radius of the hole. One style, it's probably not the best example of how to use that tip, but it is an example of how you can get it on the inside of features, or you can get it onto a shoulder. A clearance. If it's difficult for you to get the I'm gonna loosen it so that I can demonstrate it, but normally you would want it very tight, but you can get onto shoulders that are difficult to clear without some sort of angled tip. So you have many styles to choose from. Choose the style that works best for your situation. Now when we talk about calibration, it's pretty much the same as when we did the test indicator. You're going to use multiple sizes of drop gauge within the working range. So I'm going to grab a tip, and once you use your machinist square to get you in the ballpark of vertical, we're going to grab a few blocks. How about we grab the 0.30, the 0.60, and the 0.90, 0.80. And we're going to check the indicator travel. So first of all, I'm going to zero it on its granite. Apply a little bit of pressure. Hopefully you can see the reading a little bit. So got 0 right there, and fix it. All right, so now when I go to take a 30 thousandths or 0.3 of an inch that way. Do we still have 0? Yes, we do. So we're dead on at 0.3. And we're going to go to 0.6. And ooh, I've probably got 2/10, 3/10 difference. So actually, no, sorry, half, maybe a half different. I know you can't really see it on the monitor because of the error, parallax error, but let's look at 0.8. Oh, and we're back to 0. So let's take a look at that 0.6 reading again. Maybe the 0.6 was a little dirty. Let's do our 0.3. 0.3 looks good. Let's do our 0.6. 0.6 looks good. So maybe I had a little dirt, a little dust on the 0.6, a little oil. And we'll do the 0.8. All looks good. So throughout its stroke, it's looking pretty consistently like it's reading. You know, I checked at 0, checked at 0.3, 0.6, 0.8, and gave me a good reading. Put those back. And, you know, before we go on to parallax error, just to reiterate, we use calibrated Joe blocks, and earlier I squared up my indicator so that it was moving up and down. So we're isolating just the movement of the indicator. We're not involving the clamp. You know, we're making sure that the indicator is perpendicular to the base, and you may need to verify the base is flat through its own calibration, because otherwise, if it's not flat, it kind of invalidates putting parts on it and then measuring. But just to verify that the indicator is in good condition, we did it with the multiple blocks. So I'm going to talk about parallax error. I've mentioned it quite a few times in this video and other videos. It has to do with reading dial indicators. You know, as you're reading these indicators, you want to be head on with it, looking straight at the indicator and where it floats over the dial. If you're coming at an angle, you know, you're looking at it from one side or the other side, it's going to give you a false reading based on what side you're looking from. We call that parallax error. It's where, you know, two lines look like they're lined up because of the angle you're looking from, but when you look at it straight on, you'll see that that's two different lines that lined up. So in this example here, I've got some pictures. You know, you could get plus or minus 1,000th, really, sometimes more if you're at more extreme angles. One time, throughout my career, I've seen a group of people standing around a gauge. They're all looking at it, and they're all, you know, one guy's doing the measurement, and all 5 people are looking at it from different angles, drawing different conclusions, like, oh, that's bad, and other people are, oh, that's good. And it's just because the one guy who's right in front of it should be the one watching. So when you saw me do the calibration, you saw me getting down and looking at the gauge directly instead of standing up here and looking at it. Even the camera might not be, definitely not at the right angle that I would want to be looking at it. So you may need to crouch down, you may need to twist a little bit. Hopefully you can orient your gauge in a comfortable position, but really try to take advantage of that. If we just try to manipulate our surface plate gauge, I'm reading, unfortunately I don't have the ability to clamp this down to anything, but I'm reading at about 62, and if I rotated it around, I'm reading at about 63, and if I rotate it around this way and I move, just happened to be in the worst possible orientation, move these little go no-go flags. So I'm reading about 63 and a little bit. Come to this orientation. Now I read about 64. And flip it over to this orientation. And now I read it at, yeah, a little bit less than 63. So that's what parallax error is. If you've heard me, you've heard me mention it quite a bit. It's can make a big difference if you have a tight tolerance, especially when you're doing rotational checks, looking for run out and stuff. That can also be a problem. So just be aware of it. Try not to let it affect you too much. So before we talk about best techniques, I'm going to do a few measurements with the drop indicator on our part here. So now that we've talked about it, I'm going to try to zero this so if you can see on the camera, the small dial here is telling me how much range I have. So I've zeroed it pretty early in the range, and then I have about a full inch of travel before it over travels. So I'm going to zero it here. So now my tip is on the bottom and I got it zeroed, and I can note on the small dial I'm between the 0 and the 1. Okay, that's important to take a look at where you are on the small dial before you start going. So keep that in mind. Now I'm going to raise this up, drop it down. I'm going to look at my secondary gauge again, and now I'm between the 3 and the 4. So I went from between 0 and 1 to between 3 and 4. So how many rotations around the dial did I go? You can either watch and count. That's perfectly acceptable. I do that many times. Or you can just do a little bit of math. So I know I moved at least 0.3. I was now between the 3 and the 4. And I am hovering, the final reading is hovering over the 10. So I'm at 0.310. And if we consult our print for where that step should be, oh, here it is. The angle block drawing PM-02, that step is 0.315. So with my indicator, I'm getting about 0.310. And because that's so far from, it's kind of far from nominal, I'm going to double check with a caliper. Let's see what we get. Get about 310 with a caliper. So my drop indicator and my caliper are confirming each other. So now back from 0, I'm going to go up to the next step, and I'm between the 6 and the 7, which means I've gone at least 0.6, and I've gone about 0.608, sorry, 0.607 according to the indicator, and the drawing says I should be at 0.610 up here in the corner. So let's do one more verification with our caliper. Again, 0.605, 0.606, 0.605. So there could be a number of reasons for the difference. It could be the surface is a little out of spec. It could be that it's not parallel from the back to the front, but in reality, it's not all that bad, and it can be hard. It can be hard to check, with a drop indicator. You've always got to lift it, move it, and drop it back down. With a test indicator, you can actually slide things around and keep continuous contact. But you don't want to do that with a drop indicator because a lot of times you'll unscrew your tip. All that friction cause the tip to unscrew and mess up your reading. So you'll see me lift it and drop it a lot. We'll do one last check on the middle there. And we are at 0.8, 30, seven, and our print says we should be at 0.840. So it's been consistent. Let's do our caliper check. 836 and a half, 837. So we're consistent with our caliper. So again, remember, you're gonna either count how many rotations you get, or you're just gonna do the math from the small gauge and add those together. And my point earlier about different face styles. Oh, we've got to scroll through the entire thing, so bear with me. My point about different face styles, I've got a gauge that's set up for me to lift the part, and when I lift the stylus, the counter goes 10, 20, 30, 40, 50. But if I had the opposite style, if the number's counted backwards and I lift the stylus, it starts going 100, 90, 80, 70. That makes the math that much harder because you can't do a direct reading. Your last number, you've got to do 100 minus your final reading to get the complementary distance. It's tricky. So to demonstrate that, I went and zeroed from the bottom of this surface plate, and then I raised it up to get a depth. So we're going to do the opposite. We're going to zero on the top and drop down. And I will show you what can go wrong if you try to do it that way. Now our print is set up. If you look at our print, set up for datum A to rest on the surface plate. But the engineer could have easily put datum A on the top surface, in which case you zero on the top and drop down. So if we kind of look at our print, we say from the bottom it's 840 to that highest step, I should say. 840 from there to there. So if you do 1 inch thickness, subtract that, what does that become? 0.160. So I should get 0.160 on my drop gauge. I'm going to verify that with my caliper. So I'm getting about 0.160 with my caliper. But let's see what happens when we throw it on the height gauge, or on the drop gauge. So, can you see that well? All right. So I'm going to zero it. I'm going to zero it. And this time, to make things a little easier, I'm going to count how many rotations I got. So I'm zeroed on the top surface. I go 1 rotation and then a number. So my number reading is 38. So I might conclude, hey, 1 rotation plus 0.038, I moved 0.138. But if you watch the indicator, is that what actually happened? I zeroed here. I go one rotation, and then I actually go past the 50, 60. I actually moved about 62, so 0.162. So I'm not able to take a direct, just look at the number and see how far I went, because this gauge, this style of drop indicator is set up for me to always raise from 0, not to drop from 0. So just keep that in mind. There's many different styles. When you're purchasing, maybe think about what you're going to do most often. You're going to be dropping a lot. You're going to be raising a lot. There's other styles that go 0, 50, 0, which are symmetric in some ways. So you can go either way, but just keep that in mind. I can still use this gauge, right? I just got to do a little bit of extra math. So go ahead and review those measurements again. If you didn't understand that, watch how, actually watch the indicator move. And so that it will always tell you exactly how far it moved if you watch it and count. All right, so we're near the end of our discussion overall. talked about test indicators, drop indicators, height gauges, surface plate. We're going to end our discussion with the best techniques for indicators, and specifically dealing with round parts, which we're really going to talk about a lot in the next video. But because we're spending so much time with indicators in this video, I want to set up for the next video the best techniques. When you're using a drop indicator or a test indicator, you need to be right on center line with round parts. If you are off center line, which I'm gonna set up a round part, so bear with me for a minute. So I'm going to set up a round part in a matched pair, and when you go to measure this part, whether it's a test indicator or a drop indicator is unimportant, but you need to find the center point. Actually, let me do this all on camera. All right, so what I'm going to do is I'm going to sweep to find the center. The high point, actually, sorry, and that will put me directly on line with the center. And this is important because in order to repeat your measurement, maybe you're going to do a circularity or a run out measurement. In order to repeat, you have to be able to put the indicator back in the same place, for one thing. So you have to always pick the high point, because that's the only thing you can do repeatably, is sweep this around until you find the high point, which I think I've slid off of my location. So that's one reason. The other reason is if you're off center, you're going to get less error, right? You're not getting all the deflection force moving in a perpendicular direction relative to the indicator. It's going to be a little bit less accurate that way. So you'll get better results, which might be good, you think, but when you go to use the part, you get some bad readings. So you definitely need to make sure you find the center point by sweeping the part, dropping the indicator on the center. Get a nice big flat tip. When you go to use it, get a nice flat tip on your round parts. That way, even if you are a little off center, it won't matter. But remember that's really important if you're going to be using indicators, is in any application, not even just surface plate applications, but any application where you're using an indicator on a round part, you need to find the center. I want to thank you guys for watching this video, and please check out Pragmatic Metrology website for more. I'm going to be doing a demonstration exercise, so check out that video for using this equipment to measure some parts. I need to thank the Laney Community College in Oakland, California. Let me use some of these parts to demonstrate how to use these tools. They've got a great program there if you want to learn about manual machining or CNC machining, metrology and quality control, maintenance for pumps, and CAD design, many other classes. They also have certificates available that you can earn. You can earn an associate's degree. You can do your apprenticeship with them. So they're in contact with local companies that want apprenticeships, and so it's a great program. If you're in the Northern California Bay Area, please check them out. That's Laney Community College in Oakland. And once again, please check out my website for more videos, pragmaticmetrology.com, and I'll see you for the next one. Thanks.